Okay guys, I'm out here just doing a dry run with a program, and basically it's to check to make sure, send it back to 0. Yep, it's just what I wanted. The other day I was out here kind of running it through, and after I had set the router on there, I didn't even have the router tightened up, I just had it sitting in there. And I noticed that I was apparently losing some steps when the Z-axis would go back up. When it came down it seemed to be fine, but when it would go up it was slipping or something. Probably because it's still a little tight, and I was losing some steps because I could set the 0 just like that, and then when it got done running the program it would be, it would be lower. So I knew it was losing some steps on the way back up and losing its position. So I went in and got some white lithium grease, put a little bit on the lead screws. You could probably see some there maybe, and just to lubricate them a little bit, and that seems to have cleared up the problem. So I set this right on top of these 3 pieces of 1/2 inch MDF, and you can see it's scraping it just like it was when I started it. So that's all fixed. One thing I did want to do today is I wanted to talk about some of the changes that I decided to make. Actually, it'll make it a little easier. One of the changes that I wanted to do is when you put these bolts through here, back when I put all this on, I had the back off, the back panel off, and you just run it through the hole, and you adjust this with this slot where it needs to be, and then you tighten it with a nut and stuff from the other side. And I decided that's too big a pain in the butt because if this should vibrate loose or something, you don't get it tight, and you need to adjust it. You don't want to have to pull that back off again. To me, that's just way too much work. So all of these screws, with the exception of this top row, because they go in a dowel nut that help hold in the top panel there, but all of these, the lower screws on this upper rail and these screws on this lower rail, what I'm going to do is I'm going to change the hole in this panel here to be a 5/16 where you put a 1/4 20 T-nut in there on the back side. That way you don't have to, you can just stick a screwdriver right here, tighten it up or loosen it up. You don't have to worry about a nut falling off or anything like that. I think that would be a good improvement to this design. The other thing I did, and I want to show you, is I changed this whole deal around. Let me move the camera in just a little bit closer so you can see what I was talking about. Okay, let me go ahead and pull this router out of here so you can see it a little better. But one thing I wanted to do is I didn't like the way this original design was. This piece was right here, and it came down just like that. Actually, you can see it's higher, and then this piece went like that, and it all bolted into this Z-axis assembly. Well, the thing I don't like about that is once it's in there like that, I mean, it was fairly solid, but you're really restricted by whatever size mount you've got on here for a router. Like for right now, I've got this made where I can use a Porter cable 890 or a 3.5 inch diameter router. But let's say you were in the middle of a job and all of a sudden your router crapped out on you, and you had to run to Lowe's to get another one, or Home Depot or somewhere, or hardware store, and all they had was something that wasn't a 3.5, and you wanted to go ahead and get it and finish up the project. You kind of screwed as far as this design, because it's just too much trouble to have to take all this off to get to it. So what I did is I decided to make more of a router mount plate that will be for a this one's for the Porter cable 890, but if I want to take it off, I recut another front plate right here. Let me see if I can get these off real quick, and I will show you what I did here. Okay, so what I did is I made this plate, and you can see I recut these router mounts, and this is for a 3.5. It works with most Porter cables, and it may work with some Bosch or something, as long as the body's 3.5 inches. And then I cut a dado in here, if you can see that, and I glued and screwed this. And then I put matching holes right here that correspond with these holes right here, and in the back of this piece I've got a 1/4 T-nut, so you can screw that in and fasten it without having to take any of this other stuff apart. So I think that's a big improvement. I know I wouldn't have liked it the other way. So I'll get my drawings changed to reflect these changes, and that will be what I upload to the website. But anyway, I think that's going to work a lot better. Another thing I want to talk about today is how to set up some of these things. Once you get your machine all put together, you have to know some of the settings to put in Mach 3, and basically Mach 3 is going to be the only controller software I'm going to be able to help anybody with, because that's all I've ever used. As far as I'm concerned, it's one of the best out there. There's lots of choices, but a licensed version of Mach 3 costs $175, and to me that's a steal, considering as good as it works and what you can do with it. It'll control 3, 4, 5, 6 axis. It's just easy to learn. The manual's real long. I think the manual's 100 and something pages, but if you're like me, you just kind of use what you need to use and don't worry about all the other little bells and whistles, But anyway, let's talk about, let me move the camera around and let's talk about how you determine your steps per inch. Okay, I want to talk a little bit about how you set up the Mach 3 so you can run your CNC machine. This is basically the home screen here, where you would load your program, and you got your digital readout here and your cycle start and stop and those kind of things. And we'll be going over a lot of that stuff as well when we get a little farther into it. But right now I wanted to show you how you configure your machine. The first thing you do is up here you've got File, Config. So the second one over, you'd hit Config, select Native Units, and if you're setting this up for the first time, you would set it for either metric or the English G code. Mine is obviously set up for the English G code. That's the units I like to use. You can set it up for metric as well. It doesn't make any difference. But once you set it up, that's you need to set that the first time and pretty much leave it alone. You can click that there. You see mine set to inches. Okay, the second thing down is ports and pins. These things run off of a parallel cable. Now you can use some other items. You can use a USB smooth stepper and different things like that, but just for the basic setup, which is what I prefer, because you can just get an old cheap computer, doesn't have to have a lot of computer horsepower. Like I mentioned the other day, this is a Pentium 3, and you can just buy an old one at a garage sale or Goodwill store or wherever. Just find an old one, make sure it's got a parallel port, and you're good to go. If you get one of the newer ones, you may have to purchase some extra hardware and things to make it work right. But old computers, or you can pick one up for probably less than $50 at a yard sale or something, and that's what I would recommend. But this port right here that's enabled, this is basically just the parallel port that's on the back of this computer, which would be just like if it was hooked up to a printer. The kernel speed is always going to be 25,000 hertz. That's what you get for your best operation. Motor outputs is, here you can see I've got a 4-axis kit. I've got 4 stepper motors, so I've got an X, Y, a Z, and an A. And you can see I've got green checks by all of those. They're all enabled. The pin for the X, the step pin number's 2, the direction pin's 3. For the Y, it's 4 and 5. For the Z, it's 6, 7. For the A, it's 8 and 9, so on and so forth. Okay. The input signals, here again, I've just got X plus, Y minus. You can see what I've got turned on. I basically got the X, Y, Z, and A all turned on. for the output signals, I don't really have anything turned on there. And I think that's pretty much spindle speed. That doesn't really apply because I'm using just a handheld router on there. So that's pretty much what you would need to put on that one. Okay, now if I come back to the motor tuning, this is where you have to know your steps per inch, and I hope you can see this in this shot. But right here is where it says steps per, and I've got 3200, and the 3200 is the number that I have to use to make this machine move correctly using 1/2 by 10 5-start Acme lead screws. Now the way you figure that up is, the formula is you take the amount of revolutions to move an inch, which in my case it would take 2 revolutions, so you have 2 times, and then the next part of the formula is 8 over 1/8, because these are 1/8 stepper motors. They're set up to a 1/8 step. So 8 over 1/8 would be 8. So I've got 2 times 8 is 16. And then you take that times the motor revs, which would be 200. These 1/8 stepper motors are 200 revs. So again, you take the 2 times the 8 is 16, then the 16 times the 200, which gives me the 3200, and that's what I would put right here for my steps per. This is the x-axis that we're looking at. If you look at the y-axis, you can see that all of those are set, and there's the z. They're all set at 3200. Now some people might use a different pitch lead screw for the z-axis. They might use like a 2-start for their x and their y, but maybe they want like finer increments in the z-axis. So maybe they use a just a 2-start instead of a 5-start. Well, the formula for that again would be, now you've got 5 revolutions times the 8 for 40 times 200. So you would have 8,000 in the steps per inch if you had a 2-start. If you had a 1-start, that number right there would be 16,000. You know, I'll have all this stuff. Don't worry if you're not catching this right now, because I'll have all this stuff on the website. And you know, what I used to do is, when I was building these things, I would set the machines up, and I would actually take screenshots of all these different pages, so that everybody knew exactly. I said, all you got to do is pull that screenshot up, go to your Mach 3, pull it up, and make it look exactly like whatever numbers I have in there. Put exactly what I've got, and it's a no-brainer. And usually most people could handle that without any problem. The motor home soft limits, again, you can see here it says reversed, and I've got the Y checked as reversed. That's all kind of depending on which way you want it to go. You kind of set that up based on the arrow keys that you use to jog the machine. I like to make it where the arrow keys, like if I want the machine to move to the right, I'm pushing the right arrow, and it, you know, it makes it easy to remember which way you're moving things. Another thing here is the slave axis. Now, like I said, I'm using a 4-axis kit. I've got 4 stepper motors, and we're using 2 on the long axis, which I'm calling the x-axis. So if you look right here where it says x-axis, excuse me, it says slaved axis, and I've got a check in the A, which means that it's telling the motor in the back that's on the other lead screw to move in sync with the other one on the right. So those 2 motors are going to move just as if they're one. So, and you can change that. You can move these axes around and make them, you know, whatever you want, but you need to make them where it makes sense for the movement of your machine. Okay, I think that's probably all I'm going to talk about on this one right now. I don't want to get too long-winded here. Okay, that's going to do it for the video today. If you got any questions about this build or any comments, please be sure and leave those below. If you haven't subscribed to my YouTube channel already, please do. And you can follow along with, you know, not just this build, but all the other projects I do. And if you're interested in building one of these, be sure and check my website. I'm going to have the plans, like I mentioned before. I had some revisions that I did. And tomorrow is supposed to be a rainy day. It's supposed to rain all day, so it's a perfect day for me to stay inside and sit at a computer and finish up these plans and get the full-scale DXF files and all that uploaded to the website. So hopefully I can get that done, and you'll be able to go up there and get them and start working on building your own CNC. But anyway, if you got any questions, let me know. Thanks again for all the new subscribers. If you like what you're seeing, please click the like button down below, and I guess we'll talk to you next time. Thank you.